I can't see any of you, but hi. I'm going to talk about observability. And in the beginning was the Word, and the Word was God. I don't remember my Bible very well. But let's start with the creation myth. Back when computers started to become user-facing, there was a really virtuous cycle. There were users who used the programs. There were programmers who wrote the programs. And often they wrote the programs in prod. And then computers became important. The internet systems started getting bigger. And so we started to specialize, right? This is when all these roles, oh, thank you, popped up, like dev and ops. And we realized that these systems were fragile, and so we created build pipelines. Hello, Jenkins conference. All of these things were good. They were necessary. But what we lost was that feedback loop, right? We lost that virtuous cycle where the people who were writing the code were the people who felt the pain of the brokenness. And it's not just about, it is about building better services. It's also about providing a better experience for our users. But beyond that, it's about quality of life. Because when you read the social science about what makes people happy and fulfilled at work, it's all about autonomy, right? And creativity, and having a sense of ownership over outcomes. And, right, creation myth. The DevOps revolution was really an attempt to kickstart that feedback loop again. So my metaphor gets even worse. There's an apple in there somewhere. Not really sure what it's supposed to represent. But if we take a step back, this is a story about software ownership. And if you boil down ownership to its basic parts, to me it seems like basically there's three components. You must be able to develop the software. You must be able to deploy and roll back. And you must be able to debug what's happening with real users in production live. If you're missing any one of those three, you don't really have ownership, right? If you're just an ops engineer who just deploys and debugs, you never develop software. That's not being a software owner. And if you're a software engineer who stares at your IDE all day and never looks at prod, doesn't have permission to deploy, that's not really ownership either. And again, the reason we care about this is because it makes everything better. It makes the services better, it makes the users happier, and it makes your jobs and your lives better. I guess that makes DevOps the second coming of Christ in this metaphor too. That went to some really weird places. But observability is a missing link. Observability is one of the, so in my career, I have tried to put software engineers on call and make them owners of their software several times. Sometimes it has succeeded. Sometimes it has failed. Sometimes it has failed and then succeeded with almost exactly the same teams doing almost exactly the same things. And a lot of that comes down to observability. And by observability, when I say that, I mean something very precise and technical. I don't just mean another synonym for telemetry or another synonym for monitoring. And that's what I'm going to talk about. So let me introduce you to myself. Let me introduce myself to you so that you know what my biases are and where I'm coming from. My career, I've really made a niche out of being the first infrastructure engineer who comes into a startup after it's almost becoming a real thing, right? Where it's a handful of software engineers. They've got something that's resonating, but it's a pile of shit. And I help them grow up. I like to think of myself as sitting in that space between where beautiful computing theory meets messy reality, and yelling at people a lot. It's super fun. I'm the co-founder of Honeycomb, and I co-wrote Database Reliability Engineering. Now, if you happen to have this book and it has a horse on the cover, I can fix it for you. See me after class. Stickers, they're amazing. You can tell that I'm from ops, though, because that's how I feel about software. The only good diff is a red diff. I stand by that. I am prouder, I think, of the features that I have killed over the course of my career than anything I've ever shipped. I worked in Second Life, Parse, and Facebook, and about 2.5 years ago, I decided to leave Facebook and start a company. And you should never trust a vendor. And it's not because the good ones are lying to you, it's because they engage in motivated reasoning, right? And I can tell you, and it would be true, that I started this company to build the solution that is the only thing that I had seen work for systems of a certain complexity who are trying to do software ownership. And it would be true, but you should also know where I'm coming from. I'm trying to sell software. So I've been an ops engineer since, God, I've been on call since I was 17, which is terrifying. But I've always hated monitoring. I've always been a databases kid. And it's important to note that that's part of our DNA. We are not a monitoring company. But monitoring is very important, and you should definitely do it. The thesis of this talk is that when healthy teams with a good cultural values and leadership alignment try to adopt software ownership and they fail, the cause is usually that they lack the right kind of observability. Now, when I say that over the course of my career, when teams have failed to do software ownership, failed to put software engineers on call successfully, it's been a lack of observability. There's a huge assumption baked into there. I have had the extreme fortune, good fortune, of working on pretty functional teams my entire career. It is completely possible to fail for other reasons. But in my past, people basically liked each other, managers were basically competent, and we didn't fall prey to some of those. So that left observability. And observability, well, let's define it. It comes from control theory. And if you ask Wikipedia, what's observability, this is what you get. It's a measure of how well internal states of a system can be inferred from knowledge of its external outputs. So what happens when you apply that to software? Well, it means, can you understand what's happening inside your software and your system? Can you debug it? Just by asking questions from the outside with the tool, right? SSHing in and running strace is no fair. Having to ship new code is also no fair. Almost everything will clear up if you reboot it. Doesn't count. And this comes to choosing the right level of abstraction, right? The right granularity of detail and the right level at which to capture information so that you can construct almost any question about what's happening inside your system. Again, just by using a tool and inspecting it from the outside. You have an observable system when your team can basically track down any new problem, any unknown, things you haven't seen before with no prior knowledge. So how is this different from monitoring? Well, there's a perspective shift here. Monitoring is basically one piece of software looking at another piece of software and going, are you okay? Are you okay? How's this threshold? How's your health, right? And observability is much more about worming your way into the inside of it and making the software explain itself to you from the inside out. Makes it more of a reliable narrator, never perfectly so. This also tracks pretty closely to the difference between known unknowns and unknown unknowns. How many of you have the great Nagios? Yeah, I'm sorry. The angry fruit salad of doom. But like with Nagios, you want to ask questions of a system, you just write a Perl script or a shell script, right? And it returns 0 or 1 or 2. Perfectly reasonable for 1992. But what if you want to ask new questions? Well, it's not so good at that. And fundamentally, we have been building tooling for, I'm not even going to say observability tooling, we've been building tooling to understand our systems for 20 plus years, but we've been building it for ops' eyes. We've been building it for infrastructure engineers' eyes. When you go and look at your dashboards, it doesn't have lines of code and function names and traces. It has uptime and free memory and the stats from proc. And most software engineers kind of go, you're asking me to do 2 jobs now. They're not exactly wrong. So as Gregory said in Monodrama a couple years ago, monitoring systems haven't fundamentally changed in 20 years. They have fallen behind the way that we build software. Software is now large distributed systems. Monitoring systems have stagnated. And he said that monitoring is dead, which really endeared him to me. I wouldn't go quite that far. But what Greg was getting at was the increased need for a different way of thinking about our systems, interacting with them, and alerting ourselves. He defined monitoring as, what is it? The action of observing and checking the behavior and outputs of a system, the components over time, which is a great definition. But this is an outdated model for systems that are ephemeral, dynamic. Some percentage of your systems probably run in other people's platforms. You don't even have access to them. Or rather, you can monitor them in some way, but you can't dig deeper when things are breaking. And the things that can happen, the space has just exploded. Complexity itself is exploding everywhere, and our tools are really built for the LAMP stack era, where you had an app tier, and a web tier, and a DB tier. It was cool. You got to choose between MySQL and Postgres. Also, like a Parse, which was a mobile backend as a service. We hosted well over 1 million mobile apps when I left. To my great frustration, I found that answering questions was easy, right? I had all these tools that would answer questions that I had. But most of the time, I didn't have questions. I had a list of a few scattered reports of symptoms from unreliable narrators that may or may not be talking about the same thing, not reproducible. Maybe I had a hunch. And by the time, if I just knew what the question was, I could answer it, but what is the fucking question? Like, as soon as you know the question, you often know the answer too, but figuring out what actually is the question is hard. So I'm a music major, dropout. So I tried to do some science in graph complexity changing over time. It's basically what I came up with. But you know it's true, because I have a graph. But what is it? Well, we toss the word complexity around a lot, and I often get annoyed by it because I feel like people say something is very complex when they're just tired of thinking, and they don't want to have to like go into detail or think in any rigorous way about it. But let's look at some architecture diagrams. Here's a LAMP stack. Do you have a system that's getting simpler? Anyone? There's Parse's infrastructure diagram from a couple years ago, and that middle blob is a few hundred MongoDB replica sets, where we let engineers all over the world who we'd never met just write database queries in their mobile app and upload them, and we just got to make it work. On the same replica sets as other customers that were also uploading crazy-ass queries and do 5x full table scans and just make it work. And don't let anybody be affected by their neighbors. Let me talk to you about co-tenancy problems. And they did the same thing for JavaScript. There's another blob in there that's just like, write any JavaScript you want. We'll run it in containers. Never do this. It's a terrible idea. But it gets worse. That over there is the national electrical grid. And increasingly, when you're thinking about how to build and understand your systems, that's what you want to have in your mind, right? You want to be thinking about your systems as those are as unpredictable and weird as the national electrical grid, not the predictable LAMP stack. Some problems are going to be only hyperlocal, right? A tree fell over on Main Street in bumfuck Iowa. Could not have predicted that would happen today. Shouldn't try. It would be a waste of your time to try or to write unit tests for a tree falling over every single street every single day. Some problems are only possible to see when you zoom way out and look at the systemic issues, like if all the bolts that were manufactured in 1984 are rusting twice as fast as all the other bolts. When do you need to replace them? Well, you got to zoom way out. And every level of abstraction in between, any of them can be the answer to the problem that you seek. And this shift from known unknowns to unknown unknowns. For a long time, you could pretty much build a system, look at it, predict how it was going to fail, write a bunch of monitoring checks. You'd get about 70 or 80%. Then you'd put it into production. You'd just start, paying that price down, get paid, and over the next 6 months or so, you would work out the kinks, and after that, you'd get paged, and you'd be like, go to the run book, do the thing, get paged, oh, it's that one, go to the run book, do. Increasingly, that doesn't work. It used to be that maybe twice a year, I think at Linden Lab, twice a year we'd get a problem that was really stumped us, it was, all hands on deck. Who knows what it could be? Oh, this one time it was great. A printer of ours, if you accidentally pinged its port, it would just start spewing reams of paper out. It was so weird. Not a production problem, but very, very mystifying. But that's not how distributed systems behave. It's much more like you look at the system, you predict how it's going to fail, you guess maybe 20% of the cases, and the rest of them are very unpredictable and very rare, and you have to exercise different processes and muscles in your brain. Your tools were not built for this. Your brain isn't built for it either, but not much I can do about that. Often the tell is that your tools, they do some sort of aggregation at the input, or they rely on schemas or indexes, or anything that is enforcing a shape on the data or on the query path before you're actually accessing it. Also, how many of you have many different tools and you find yourself jumping around trying to correlate what the spike in this one and the raw requests in this one and the symptoms over here? It's really annoying. Converging trends, we're all familiar with these. But here we are. Welcome to distributed systems. You're all distributed systems engineers now. You should probably ask for a raise. It's probably fine. It's definitely not fine. First lesson of Distributed Systems Club. Your system is never up. It's never 100% alive. It may, if you're lucky, asymptotically approach all up, but more likely, you just don't know where the problems are. Your tools probably are not good enough or fine-grained enough to show you. But I guarantee you, if you have a production system, so many catastrophes lie waiting in it right now for you to go to sleep, probably. That good feeling that you get when your dashboard is all green is a total lie. Because distributed systems have a basically infinitely long list of almost impossible things that happen twice before breakfast, and they make staging basically useless. Staging is the worst black hole for engineering time. It will never be in sync with prod, ever. Every time you deploy is a unique combination of that artifact, that time in an infrastructure, like slice of an infrastructure, and the tools you use to deploy it in the environment. You can test all you want on staging, even if it matches perfectly. Then you can typo the environment name, and you're still screwed. And we have a limited number of engineering cycles, right? This is what kills me. We have a limit. It's the hardest cap in the universe, and yet we waste our time on all this infinite staging shit instead of taking some of those cycles and applying it to hardening production, to building guardrails so that you can ship more safely, so that you can have canaries, so that you can have feature flags, so that you can ship things and flush out bugs without your users ever having to see them. Testing in production is not a bad word. I should be wearing my shirt. It says test in production. That meme, I don't always test, but when I do it in production, is funny, but I hate it because it implies that you can only do one of the two. Let me tell you, you can do both. You can run tests before shipping to production, and you can then perform controlled tests in production. That's a different talk. I keep going down this rabbit hole. Let's get back to observability. Observability is the missing link that empowers you to test in production as well as putting software engineers on call if you're paging alerts. Because the entire point of this is that if you can't tell what's happening, you probably shouldn't experiment. What are you going to learn if you can't tell exactly what's happening? You're not going to learn much. Anyway, I've been very high level here. Let's try some actual concrete examples to illustrate what I'm talking about. So here's a version of a question that we've all debugged at some point in our career. Photos are loading slowly for some people. Why? And in the LAMP stack era, answers looked often like this. Out of capacity, latency's high, out of connections. Cool, monitor those things. Characteristics of these systems. Pretty friendly to intuition. Dashboards are great. You can see the health of the system at a glance. And the health of the system, this is important, if it's like 99.8, then 0.2% of 0.2% of 0.2% of the time, somebody's getting an error, and it's pretty evenly distributed because they're all sharing all of these tiers, the pools. Cool. Best practices. Every alert must be actionable, right? That's like commandment number 1. You should not have to look at the monitoring system all day. It should inform you proactively when something's broken. And run books and documentation and all this stuff. Great. Now let's look at the same question. And these are real examples of failures that were taken from Parse and Instagram. Look familiar? I mean, what exactly am I supposed to monitor for? I'm not sure. I've got more. I can do this all day. I can do this all night. This remains perhaps my favorite bug. They came to me one day and they're like, push is down. I'm like, push is not down. It's in a queue and I'm getting pushes, ergo push is not down. They were very upset. And they came back the next day and they're like, push has been down for 24 hours. Finally go and investigate. This is the time when Android devices had to keep a socket open to the server at all time to subscribe to pushes. And we had added more capacity to the autoscaling group, which exceeded the packet size for UDP, which is usually fine, right? It fails over to TCP, no big deal, which it did everywhere in the world except this one router in Eastern Europe. They thought push was completely down. Anyway, these are all super unknown unknowns. You could never have predicted. Like, what am I supposed to do? Like, request root in every router in the world and monitor how they look up? That's just absurd. And it's not a good use of your time to take the traditional steps of hold a postmortem, ask yourselves what monitoring checks can I write so that it will page us immediately about this exact problem the next time it happens, write a runbook for it, write some documentation, make me a dashboard so I can find it immediately the next time. It's just a waste of time. And if you do that after every outage, you just build up a shitload of them. And then you can't find it's a whole rabbit hole. Characteristics of this system. Unknown unknowns are most of the problems. This also assumes a pretty high-functioning SRE team or ops team, where you're getting paged and every time it's something new. That assumes that you're using your postmortem energy to automatically remediate all of the problems that you do know about, right? That assumes that your management is giving you enough time to do this. It's not always true. Many components in storage systems, and they're often partitioned, sharded, horizontally distributed. You can't model the whole system in your head. You really shouldn't try, right? You should lean on you should have that in a tool where you can explore it, where everyone can explore the same information instead of mapping it in your head, because things will change and you won't know about it. The hardest problem is often identifying where the problem is coming from, which component is at fault, especially when the system loops back into itself, right? In that case, theoretically, any component can infect the entire system. And the health of the system, so to speak, is basically irrelevant. The only thing that matters is the health of every individual request, every event from end to end. And this is important because, imagine if your uptime was 99.8% again, but this time, instead of it being evenly distributed 0.2% of the time, it is 100% down for everyone who lives in the shard, for people whose last name starts with S-H-E-N, right? Still 0.2% of all requests, but they are completely down. This is a super uncommon type of problem that we see in these types of systems. And they'll often not even show up on your time series aggregates. Often at Parse, like every day, somebody'd be like, Parse is down. I'd be like, Parse is not down. Like, behold my wall of green dashboards, the holy wall. Maybe it's Disney. Maybe they're doing 4 requests per second, and I'm doing 100,000. My entire system never even going to show up. Their errors are not even a blip on any of my dashboards. So I would have to dispatch an engineer or go look myself and try to track down exactly why Disney's little trickle in the ocean seems to be completely down. And maybe it's their fault. Maybe they uploaded some code or a query or something that's busted. But it would take me hours, if not days, to debug all of the possible combinations of things that could be wrong, whether our fault or their fault. And that's kind of the kiss of death when you're a platform, having to spend all this time on one-offs. So, known unknowns versus unknown unknowns. Very different tooling. And next, and last, this is the last section, last third or so, I want to talk about the types, the characteristics of systems. You know, if you use Honeycomb, the cynical person might say, well, boy, this looks like a list of things that Honeycomb does. And I would be like, you are right, because we made those decisions, because we knew about this. But when you're evaluating tools, look for these things, because they matter. And I think that the entire industry is moving in this direction. Again, even brilliant debuggers, when they have the wrong data or the wrong tools, really struggle. So first of all, hunting unknowns. This is an instrumentation game from start to finish. It's all about getting inside the software's head and explaining itself back to you. And the place to start, I'm not going to go into all of the instrumentation stuff, but you basically want to generate one observability event per service per request, right? So if you have microservices, it would be that hits 12 microservices and 5 data stores, and that would be a total of 17 events that are all glued together by a unique request ID that you trace throughout the system, blah, blah, blah. But the place to start, if you do nothing else, the place to start was every network call. Instrument every network call, wrap it, store the time that it took and the payload, what it did, because that way, at least, when you get into one of these states where a component is infected the entire system and latency is rising everywhere, you can trace it back to the origin using that. Events, not metrics. Now, ops has been big into metrics for the last 20 years, and I think that sucks. I think it's a big mistake. Now, yes, they're very cheap. They're very efficient, but they have some huge weaknesses that basically cut you off at the knees if you're trying to debug systems like this. Starting with cardinality. Traditionally, metrics do not support high cardinality. When I say high cardinality, what I mean, imagine you have a collection of 100 million users, and things like social security number or any unique ID is going to be the highest possible cardinality. Somewhat lower, but still quite high, would be first name, last name. Gender is going to be pretty low cardinality, and presumably species equals human is the lowest of all. So, what kind of information do you think is going to be the most useful when you're trying to identify a rare event? The high cardinality stuff. Completely always high cardinality stuff. And not just 1 or 2 high cardinality dimensions, but lots of them, right? If you're looking for something that happens only 1 in a million times, when it overlaps with a 1 in 100th time, you want a lot of unique data, and you want a lot of context, right? You want to bundle together as many things and say, these were all true of once. All of these things describe this event as it's wending its way through my system. Now, some newer metric stores, I think, are starting to ship things like key value pairs in the tags for metrics. Any of you here use Cassandra or Datadog or any of that stuff? Any of you use that and not blown out your key space? Yeah. True story. My co-founder, Christine, wrote the Parse metrics product. And we based it on Cassandra, and she got so freaking angry. Our users would write in and be like, all I want to do is ask this simple new question. And she would be like, can't be done because we didn't gather that information in this format. Let me go over to Scuba and fetch it for you by hand. High cardinality is not a nice to have. And the other thing about metrics is that they're very schemaed, right? They're very predictable. structure, and you want to be able to be unpredictable. You want to have an elastic, a flexible number of tags, I would say dimensions. But like the thing that transformed our life, getting our stuff into, so by the, well, let me back up. Around the time we got acquired by Facebook, I was coming to the horrified conclusion that we had built a system that was basically undebuggable by some of the best engineers in the world. Hours or days to track down these problems, and I tried every tool out there. We were losing ground, like we were spending all of our time tracking down these one-offs. And the thing that finally saved our ass was getting some data sets into Facebook Scuba. Any Facebook people here? So Scuba is this janky-ass, aggressively hostile to user tool that was hacked together overnight in a hackathon 10 years ago when they were going through their big MySQL problems. It's really awful. And yet, it does one thing and one thing well. It lets you slice and dice on arbitrary dimensions, high cardinality in real time. And we got some of our data sets into that, and our time to tracking down these weird one-off problems dropped like a rock from hours or days to seconds, maybe minutes, like predictably every time. All of these engineering problems became support problems. And that experience, well, I'm an ops, so as soon as it was working, I moved on to the next thing. I never really stopped to think about why it changed, it was so dramatically effective, until I was leaving Facebook. And that's when I suddenly went, huh, I no longer know how to engineer without this stuff that we've built. I was planning on going and being an EM at an engineering manager at Slack or Stripe, but I realized that not only had it become so key to how I debugged problems, but the entire process of deciding what to build, validating what I had built, shipping it along the way. It's like when you're as blind as I am, it's like somebody telling you you can't have your glasses anymore. You're just like, whoa, hold on. So I wanted it so badly that that's why we built Honeycomb, to try and make a slightly less aggressively hostile to users tool. Anyway, high cardinality, it's not a nice to have. The key thing about Scuba that dropped our time to remediating these problems was just this, the ability to break down by a single app ID, maybe 1 in 10 million, right? Break down by that one app ID, and then any combination of everything else, right? Endpoint, latency percentiles, et cetera, errors. That's it. And it's basically like, I mean, if you're a platform, have you ever pre-generated dashboards for a couple of your most important users? Well, it's basically like that, except for all your users, except they're not pre-generated. You're just asking the question, you know? Just like Disney, okay, well, which endpoints are slow for Disney? Well, break that down, okay. Looks like the slow ones are all write endpoints. Interesting, so it smells like a data store problem. What data store are they timing out talking to? And did they upload a query, you know, and boom, you find it. It's so easy. One of the hardest problems we have is just trying to explain to people how easy it can be. Anyway, no limit on the amount of detail and context. That's important. Context is everything. Context, if what you're looking for is outliers, then you need the ability to knit together as much data as possible. Arbitrarily wide events, structured data, structuring your logs at the source. Who here is wearing the cone of shame of still using unstructured logs? Nobody's fessing up. 1, 2, bless you. You should fix that. It's 2018. There's no excuse for strings and logs. It
is when you're working with systems 40 years ago.
Oh, well, all right, you're absolved. And by the way, when I say events, I mostly just kind of mean structured logs that don't write to disk. Logs just have a lot of baggage. Dashboards, I also hate dashboards. Let me tell you why I hate dashboards. You're jumping to the answer before you ask the question. Every single dashboard is an artifact of some past failure. It's technical debt. What happens every postmortem? It's like, well, okay, well, we figured out what went wrong. It took us 2 hours to find it. Let's create a dashboard so we can find it immediately the next time. Okay, fast forward a year down the line. How many dashboards have been created? And they just accumulate like cruft, like dust bunnies. They need to die. You don't want to have the approach of looking through answers to find your question. I think of this in many ways as like a BI approach, right? In BI, do they start, when they're trying to explain some user behavior or why some cohort is doing something or other, do they start with a bunch of dashboards and flip through them to see which one matches the pattern that they're seeing? No, that would be insane. Think about how much you would be missing if you just jump straight to the answer. They ask a question. They start with a small question about the user behavior. They look at the answer based on what it is. They ask another question, right? And it's like you follow the breadcrumbs until you go to the actual source of the problem instead of just like flipping through them. Also, dashboards are just exercise for your eyeballs. And it's just like, no, that's not science. Scanning with your eyeballs and looking for patterns and spikes is not science. And it does not help you be a better engineer. I think it fundamentally makes people worse at engineering. By the way, exempt from my criticism are dashboards that allow you to drill down. They don't count. They are fine. Sometimes better than fine. I'm only ranting about the ones that are static. And no matter what, you must be able to get back to those raw requests. This means that it's probably going to be cost prohibitive to not sample or aggregate at some point, but you need to keep the raw requests or some percentage, some sample of them for some time. I'm a big fan of dynamic sampling, where based on the type of data, you sample it, you give it a different weight. So for example, web data, 200s, they hit the homepage. Sample those heavily. You already know they're fine, right? For 500s, keep them all. And for 200s, for less common endpoints, maybe sample 1 and 5, something, depending on your costs and your traffic. Imagine, like at Facebook, every web request that came in generated, hundreds of web requests. And every single event that came into Facebook's front door generated something like 200 or 300 internal events, just the various observability stuff. Now, no one is ever going to pay for an observability stack that's 200 or 300 times of production. It's just not going to happen. So either you tell your engineers that they have to be very, very stingy about what they gather, or you sample. And you do not want people to be stingy with debugging information. That's one of the reasons it's been so hard for us to track down problems in our systems, is because we're being stingy when we gather, when we need to be profligate when we gather. Gather everything, and then deal with the costs through sampling. Think about temperatures. The temperature in San Francisco, that is a sample that is taken throughout the city. Aggregation is a one-way trip. If you want to have observability, you have to be able to ask new questions. Well, if you have aggregated at the time of ingestion, you can never ask any new question that you didn't aggregate for, right? You want to do read-time aggregation. Like, imagine that your interval is a second, well, and you have 10,000 requests. Typically, these systems, they will smush all of those 10,000 requests into one number for that second. You can never unsmush that. You can never get back to the raw events. So good luck tracking down any outliers. Aggregates will destroy all your precious details and your context. I feel rather strongly about this. But you can't hunt needles in haystacks if your tools don't handle extreme outliers. And it's not really hunting a needle in a haystack so much as it is hunting a needle in a pile of needles that are probably on fire. But let's look at some examples of, if you have access to the raw events, and if you have an exploratory type of approach, these are some of the small journeys that you might go on. It's really fun. Have you ever put a software engineer on call and watched their eyes get big and they're like, oh, there's an error. And you're like, yes, grasshopper, there are errors all the goddamn time. But that's terrible. It's a good instinct to see a problem and want to investigate. It's just that we've learned to tell them not to because we know that it's just going to lead to frustration because they aren't actually going to be able to figure out why. But what if you could? Think how satisfying it would be to understand any error that you looked at. In conclusion, users do not give a fuck about what your system health is. If your system is, like, if you have distributed your traffic across 3 availability zones in Amazon, right, and one of them goes down, should you care? No, you shouldn't care. Neither should your users. They don't care what your system health is. It can be 30% down. All your dashboards can be red. Users do not care as long as their requests are succeeding. Services need owners, not operators. Owners who want to understand what's happening underneath the covers. Owners who care about what happens after they push deploy. Because ops isn't going away, ever, guaranteed. But increasingly, we live on the other side of an API from developers. And everybody is responsible for the operability of their own systems. I feel like the first great wave of DevOps was yelling at ops people to learn how to write code for like 10 years. Like, write code! I'm like, oh, okay. And that was a lesson we needed to learn. But I feel like for the past couple of years, that pendulum has been swinging back. And now it's much more about, okay, software engineers, your turn. Learn to write, learn to build operable services. Learn to take responsibility for that which you put forth into the world. And ops is here to help, It'll be a few years. But never promote someone to senior engineer if they do not take responsibility for their own operations. Instrumentation is a big part of building software. So let's give developers the observability tooling that they need. And this means tooling that speaks their language, that isn't just talking proc stats and memory and all of the infrastructure-related things, but it talks to them in terms of lines of code, right? Functions, things that are familiar to them when they go and look at that dashboard and start exploring. Observability-driven development, I feel like this is a successor to TDD. TDD is very limited in an era of distributed systems because testing breaks at the border of your laptop, right? It only extends so far. And you really want to start observing before you've even written a line of code. You want to know whether something is worth building or not. You want to know how much efficiency you will reap. You want to know, how your users are behaving once they're inside your system. And that means watching it in production. There is no substitute to watching how your code behaves once it's talking to real services over the real flaky internet, using real data and real unpredictable user patterns. So tonight, we test in prod. And that's the end. Oh, wait, one more thing. This is what you win. Like, in exchange for all this pain and suffering, because it is harder, right? Observability is it's more of a hurdle to get going with than simple monitoring. But I feel like once you've made the switch, once you can actually ask new questions and diagnose new problems, you can go and delete 90% of your alerts, right? Most of them don't exist to actually alert you about important things so much as because it's so hard to debug and find the source of the problem. If you can just do that, you don't need to get paged about anything except latency, errors, request rate, for top level and for each major service if you're microservices based, and for a couple of end-to-end checks that stress the critical code paths of whatever makes you money. That's it. When one of those goes off, you hop on, you diagnose it. That's all there is to it. Now I'm done.
Okay, thank you very much. Do we have any questions in the room? Yep, there's one question there.
You guys must be tired. Long day of Jenkinsing.
Hi, I agree with you that testing in production is something that we have to do and it produces the best results. But my experience is that there's always tons of red tape to get that done.
Don't call it testing in production. You're experimenting, controlled experiments, staged. Also, and wherever possible, have a separate group for internal users and roll it out there first. And canaries, and feature flags are really your friends here. Facebook rolled out everything to Brazil first. I'm not really sure what Brazil ever did to them. But like, they'd roll out to internal users, and so if the int.prod.facebook.com went down, then, oh, well, I guess this build's bad. And then they'd roll it out to like 10% of Brazil, and then they'd wait for health checks to be okay, and then they'd roll it out to more, and it would just be this gradual process. So they'd have hundreds of versions in flight sometimes. But it's just a fact that lots of categories of problems will only ever be fleshed out in prod. So I think that the critical thing to lean on there is you have limited engineering time. You should spend some of your engineering cycles on, don't just start shipping to prod and willy-nilly. I mean, that's not the point. The point is investing in observability, understanding what's happening, and some guardrails around the process of. I believe that release engineering is the single most underinvested in part of every company I've ever known of. The deploy code, almost every problem that you ever see in prod was, the proximate cause was a deploy. And yet we're still using fucking Capistrano. There's no excuse for this.
Thank you. Any other questions? First row here.
Hi. So I think that Kubernetes is great technology, but it's a massively hyped thing right now. And the one observation I would make is that tons of organizations are jumping into building highly complex microservice-oriented systems right now. And are we about to run into an issue where software quality is going to go down rather than up?
About to. When was it going up? So I think that there's no excuse for people to be running Kubernetes themselves, from as far as I can tell, unless you are a provider who that's one of your core competencies. It's not ready for most people to be. It's going to be a black hole for your time too. It's great for this. This is like the worst example of Giphy, Google infrastructure for everyone else. It's almost like it's something done to set. What was the joke about Cassandra that Facebook developed it as a poison pill for Twitter to take down their competition? I would almost think that of Google, but I don't think they actually meant it that way. But yeah, it makes sense at Google scale. There are a few other places that it makes sense. Everywhere else, you are just front-loading, back-loading the pain so that you can get started more easily, which is not always a terrible thing to do, but you don't need fucking Kubernetes to run a container. I have feelings.
More questions here? Yeah.
Last one, I hurt my butt and it hurts.
Yeah, so my question is about instrumenting your applications.
Yeah.
There are tons and tons of events, and you could define them in a lot of different ways. What do you look for to be oh, that's a good event, I'm going to make sure that I instrument that? Yeah,
well, that's a question that has many different answers. The way that we did it at Honeycomb is obviously, I think, the best way. Where when a request enters a service, we initialize an empty Honeycomb event and some stuff in there that, language internals, some things that we can infer to get you started. But then throughout the life of that request in that service, you can stuff anything else in there. We automatically wrap, say, all MySQL connections, all MySQL queries, all HTTP requests. But you can, wrap any other type of request that you make, stuff it in the Honeycomb blob, and any unique IDs, just stuff everything in there. Well-instrumented services with us tend to have 500 dimensions. And then at the end, when you're erroring or exiting, you ship the blob off to us. And so the reason I think this is the best is because it's so wide. So all that stuff I was saying about context, it means that you can actually correlate things like, twice a year when you have network problems, and all of your time series graphs for networking stats, I really can't see, are all there's a spike, and it seems to correlate to the same time as there was some requests that got dropped. But there's nothing that actually knits those things together, right? It's super frustrating. It's very impressionistic. It's an art, not a science. But if you just take those statistics and make structured data out of them and append them to that same blob, it's negligible expense because it's just the same one write. But then you can actually actually track those actual spikes to the actual requests that errored. And that is so satisfying, so satisfying. General advice in non-honeycomb context is just, every unique ID that you can, make it so that you can reconstitute requests if you're logging, in functions or whatever, make it so that you can trace. But logs are just so terrible. And structured everything, right? That's mostly it.
Okay.
But I really like the model of one write per service, because otherwise you're going to DDoS yourself with logging events. Sorry, I'm done.
Oh, that's okay. So I think we ran out of time. If you have any additional questions, I'm sure that Charity will be willing to answer.
Totally.
There's happy hour at 5:30.
Ooh.
5 minutes ago in the hall. So let's run there, have some drinks, and talk to Charity, okay? Thank you very much.